Welcome back to Notes with Swearingen. Ooh, I hear people outside my room. This is Geometry, Unit 7. Today we are talking about 7.3. This lesson is called Special Right Triangles. Yeah, that's what the lesson is. This lesson is going to be split up into two parts. We'll say 3 parts. So 1, 2, 3. The first part is an overview. Ooh, don't stop on me now. The second part, we will look at 45, 45, 90 triangles. The third part, we will look at 30, 60, 90 triangles. Let's get into it. Part 1, the overview. Okay, we have, there are 2 types of special right triangle. Ooh. Let's put that all on the same line. And let's extend this. We have 45, 45, 90. And we have 30, 60, 90. Now, you might say, why do you give those such a weird name? Well, these numbers look at the angle measurements. Pop. So in a 45, 45, 90, we have, well, 2 45-degree angles and a 90-degree or a right angle. In a 30, 60, 90 triangle, well, we still have that 90-degree right angle, but then we have a 30-degree and a 60-degree. We will learn today these special rules. When we see either of these 2 kinds of triangles, we can figure out the side lengths quite nicely. So we'll learn today, I'll go ahead and show you these patterns that we will then talk about more in the other parts. So in a 45, 45, 90 triangle, we have the 2 sides that connect to our right angle. We call those legs. They're congruent. Then we also have our hypotenuse. Well, our hypotenuse, we will learn, is just the side times root 2. In a 30, 60, 90, and let me scoot this over just a bit, we have 2 legs, but here they're not congruent. So we're actually going to do this. I'm going to use a lowercase l to show that here's a leg that's small. It's a short leg. I'm going to use an uppercase L to show the leg that's bigger, and an H to represent the hypotenuse still. Ooh, this is a good reminder. The hypotenuse is across from our 90-degree angle. So we find that 90 degrees, the side across from it is our hypotenuse. Today, or in those triangles, we will learn that the long side, we just take the short side times root 3, and the hypotenuse is just the short side times 2. It's okay if this is going over your head. We haven't explained it. I'm just showing you this. Now, and I actually really love that red color. I will use this more. Let's get into it. Actually, let me say, pause this, make sure you have this in your notes, because this will be a great thing to reference as we continue. Okay. Part 2. 45, 45, 90 triangles. Here, we will start by looking at when we know a leg or the side and we want to find a hypotenuse. Here's an example. 1, 2, 3. Oh, I did that wrong. Here in our gorgeous 45, 45, 90 triangle, I am going to tell you, oh, these side lengths are 3. Well, if we know the side lengths, how can we find our hypotenuse? Well, if you look back, what we can do is we can just take that side length times root 2. So here, I'll go ahead and spoil the fun and say our hypotenuse is equal to 3, because that's our side length, times root 2. That's it. Like, don't overcomplicate it. It's not complicated. You just multiply by root 2. If you're curious why this works, let's figure it out. Well, let's use the Pythagorean theorem. A squared plus b squared equals c squared. Let's plug in what we know. We have our side length 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 9 plus 9 is 18. Once we get here, we need to square root both sides to get what? Well, we can break apart 18 into 9 times 2. Well, the square root of 9 is 3. The square root of root 2 we can't simplify, so we'll leave it, giving us 3 root 2, like we said before. So I'm showing you that work. You do not need to do this. You don't have to show me this at all. In a 45, 45, 90 triangle, we just know the hypotenuse is times root 2. So I'll give you some more examples so you feel better about yourself. Maybe not in life, but in math class. 1, 2, 3, 1, 2, 3, 1, 2, 3, click. If I tell you this is a 45, 45, 90 degree triangle, and I tell you this side here is 10, my question, what is the other side going to be? What is this green side going to be? Well, they're congruent, so this is also just going to be 10. And let me change to that red color because I'm loving this. This side's just going to be 10 because they're congruent. Well, what's my hypotenuse going to be? Don't overcomplicate it. It's just 10 root 2. I'll give one more really easy one, just so you can see it. Done the same. Oh, that didn't even out. What? Pretend that's the same. Okay. Another 45, 45 degree triangle. Let's make it, let's go crazy. Let's say this is 17. What a pretty number, right? The other side has to match 17. Our hypotenuse is just 17 root 2. Please, please, please don't overcomplicate it. I know it feels like it needs to be scary and complex. It's not. Do I say nice number examples? Then let's look at one that's not as nice. But interesting. What happens if our side length is 5 root 2? I'm sure all of you just saw this and gasped and screamed and yelled and cried. Ah, that's not a nice number. How do I do that and still get a hypotenuse? Well, you still do the same exact process. First of all, we know the other side has to match. So change the color to the pretty red. So this side has to be 5 root 2. To get our hypotenuse, we just take 5 root 2, we take our side, and we multiply by root 2. Right? I know it's scary, there's just one extra step. When I have this root 2 times root 2, well, that will just simplify to 5 times 2. So h equals 10. This is my answer. My hypotenuse is 10. Even if we have a radical as a side, we still follow that same times the square root of 2 process. Maybe I'll say this. Let me give you one to do on your own real quick. Nope, we are making that better. Thank you. Let me give you one let's just say 6 root 2. So here's a 45 degree triangle. Pause this video. Pause this video. Find the other side and the hypotenuse. I will explain the answer in 3, 2, 1. And really, I don't know how much of an explanation. Sides are congruent, so 6 root 2 is the other side. The hypotenuse is 6 root 2 times root 2. Almost messed up there. So we're doing 6 times 2, which equals 12. Done. Hopefully you got that. Cool. So that's the first part of these triangles. The second part, I should color code, is, well, what happens if we don't know the legs, but we know the hypotenuse? Well, we're just going backwards. So if we multiplied by root 2 to get our hypotenuse, the opposite of that, we will divide by root 2. Let's see an example. I'll start off with the nice one. So let's say we have this 45, 90 degree triangle. Let's say we have our hypotenuse is 15 root 2. Well, if we know our hypotenuse and we're trying to get to our leg, we will divide by root 2. What that means is I take my hypotenuse, I take 15 root 2, and I divide it by root 2. Well, here I see these root 2's that will cancel. So my answer here is just 15. What you just found was our sides. We're undoing that root 2. Here is another example of the same difficulty. Pop. Okay, yep, I get it. Yep. Just to build your confidence, 21 root 2. Well, we're still going from our hypotenuse to our, oops, sorry, I should be calling this, ooh, sorry, I did it again. We're going hypotenuse to side. We're calling these sides. So here we're dividing by root 2 again. Well, here, when I do that, 21 root 2 divided by root 2, the root 2's cancel, leaving me just with 21. The tricky thing is, what happens when why am I doing all this work? You know what? Let me do this. I'm going to take this and, oh! Okay, good. There. What happens if we have a hypotenuse that's not as nice, or where the math isn't as nice? For example, what happens if our hypotenuse is 8? Once again, we know it's our hypotenuse because it's across from the 90-degree angle. Just a quick reminder there. Well, if we have our hypotenuse, we want to find our side. We divide by the root 2. So let me write 8 divided by root 2. Here, we don't have any root 2's to cancel. What that means is we need to rationalize. What that means is we have this root 2 in our denominator. We cannot leave it in our final answer. So we multiply root 2 times root 2, giving us 8 root 2 in the top. And the denominator, those root 2's combine to get just a regular 2. The only other thing now is that we can simplify this even further. Now we have an 8 and a 2. Well, we can simplify those numbers. 8 divided by 2 is 4, so our final answer is just 4 root 2. So my two sides, 4 root 2, 4 root 2. We will do one more. Oh wait, and I did my pop. Ha ha ha. Ha 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 ha. Okay, this is one that you should try on your own. Let's just do 10. Hypotenuse of 10. Pause this, work it out. I will explain it in 3, 2, 1. Shoot, my Gatorade's empty. Go. Here, we're going hypotenuse to side, so we divide by root 2. Which means we have 10 divided by root 2. Uh-oh, radical in the denominator. We hate that. So we multiply by the radical in both top and bottom, leaving us with 10 root 2. Those 2's in the denominator go together to make a plain 2. Then we can simplify. 10 divided by 2 is 5. So 5 root 2 is our side lengths. Cool. Okay, I went through a lot of practice examples because I want you to see these patterns as clearly as possible. Hopefully we're seeing them. Hopefully we're able to make those connections. That is it for the 45, 45, 90 triangles. We did a lot of work, a lot of practice. Woo, 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 woo. The big thing, well, should I summarize now? I'll summarize now and then I'll do another one right at the very end. In 45, 45, 90 triangles, we learned two things. If you know the side, to get a hypotenuse, you multiply by root 2. If you know the hypotenuse, to get the side, you divide by root 2. That's the quick summary. Here we go. Part 3, 30, 60, 90. My handwriting's getting sloppy. You know what that means. What could that possibly mean? Here we go. Let's see, how did I start? Did I just go straight into examples? Yeah, I did. Let me say this. There's going to be an A, a B, and a C to this. There's 3 things we're going to be looking at. The first thing is going from a short leg, lowercase l, to a hypotenuse, and a short leg to a long leg. Really, we love the short legs because they give us these really nice patterns. Let's go smaller than that. Let me copy and paste this. Copy. So quick reminder, our things was we have our short leg, the shortest side connected to our 90-degree angle. We have our hypotenuse, and we have our long leg. We will learn that the hypotenuse is just the long leg times 2. We will learn that the hypotenuse is the short leg by times 2. The long leg is the short leg times root 3. Short leg, long leg, all these other legs, they're showing up everywhere. Let me give you an example so we can just make sense of this nice and simply. Here's my 30, 60, 90 triangle. If I know my short side, is, what's a good number? Let's just say 4. Well, I'm trying to think of a good way to explain this. To get to the long side, we multiply by root 3. So to get our long side, we take our short side, 4, times root 3. Well, that's just 4 root 3. Simple as that. No crazy business. When we go from our short side to our hypotenuse, we're just multiplying that short side by 2. So our short side is 4 times 2 gives us 8. That's it. That's the patterns. So let me write those in. Times root 3 times 2. I'll give one more nice example before we look at some more chaotic examples. Let's just say 16. So once again, to go from short leg to long leg, we will do our short leg times root 3. Well, that's just 16 root 3. To go from our short leg to our hypotenuse, we're just multiplying by 2. Well, 16 times 2 is just 32. I should have had you pause and work that one out. My apologies. Let's look at one that doesn't work out so nicely. What I mean by that is, let's see what happens when our short side is 5 root 3. Once again, I see a square root on my side. This is so scary. It's not scary. Same exact process. Short side to long side, we multiply by root 3. So I take my short side. What is my short side? It's 5 root 3. I multiply it by root 3. Well, here I have a pair of root 3's. We've learned that that's just 5 times 3. Those root 3's will combine to just be a plain 3. Meaning our long side is just 15. When we take our short side to our hypotenuse, we just multiply by 2. So really just at least write down, if you're confused, just write down, okay, my short side is this. I multiply it by 2. Here we're just combining or multiplying those whole numbers. 5 times 2 is 10. We keep the root 3. So our hypotenuse here is 10 root 3. Cool. That's part A. 4 quick examples. Nice, good, loving it. Feeling good. Part B. Part B, we will look at, well, what happens if we don't start off with a short side? Let's say hypotenuse. What happens if we have our hypotenuse and just our hypotenuse to start? So let's say our hypotenuse is 30. Well, here we learned to get to, I am so sorry. I mixed these up. Oh, this is bad. I mean, I did the math right in all the examples. I just wrote it wrong here. The hypotenuse is times 2. The long leg is times 3. Let me double check that I did that right. Yep. Okay, good. If to get from our short leg to our long leg, wow, take a minute, take a second. If we start with our short leg and want to end up with our hypotenuse, we multiply by 2. So if we want to do the opposite, if we start with our hypotenuse, end up with our short leg, we will divide by 2. So here, come on, click over. Hypotenuse to short leg. I don't know why I used an S when it should just be a lowercase l. We divide by 2. What that means is we take our hypotenuse 30 and divide it by 2. 30 divided by 2 is 15. Wow, you have just solved for our short side. Congratulations. Now that we have our short side, we'll go back to using that short side to find our long side. Remember, our rule for that is times root 3. So I take my short side times root 3, giving me 15 root 3. One more example of this that's not so nice. And when I say that, I'm exact. These are the things that students look at and want to freak out at, but there's no reason to freak out. Ooh, let me use a smaller number. Let's use 14 root 3. So here we start with our hypotenuse. So we start with our hypotenuse, meaning we will want to get our short side. Hypotenuse to short side, we divide by 2. Well, you see that and you might start freaking out. Oh, how do we divide that by 2? Just write it in an equation. Say, okay, well, maybe I'm confused right now. I know my hypotenuse is 14 root 3. Well, let me at least write divide it by 2. Maybe that will help you see those connections, because here we have 14 and a 2. We can simplify that to 7 root 3. That is the answer. You have just solved for our short leg, 7 root 3. Now we can take our short leg, find our long leg. Seven root 3 times root 3. Those root 3's will combine to end up being 7 times 3, which is 21. Whop. Cool. Ooh, stretch real quick. Yeah, felt good. It's getting late in the evening. Last thing, part C. What happens if we don't have a short leg? We don't have a hypotenuse, but we have a long leg. We will use this rule. We will divide by root 3. So a nice example. Let's say we know the long leg is 6 root 3. Well, long leg to short leg, we divide root 3. So my long leg, 6 root 3, I divide it by root 3. Aha! Those root 3's will cancel, leaving me with 6. Well, now I will go from my short leg to my hypotenuse. What's my rule for that? Times 2. 6 times 2 is 6 times 2 is 12. A different example, let's say our long leg is 14. Well, we always, if we don't have a short leg, we're always first step getting that short leg. So once again, we get there by dividing by root 3. So I have 14 divided by root 3. Nothing cancels, but I have a radical, so I have to multiply that on both sides, ending me with 14 root 3 over 3. Here, this is actually as simple as it gets. In our other problems, we've been able to simplify those numbers, like 14 over 3 would simplify nicely. Here it doesn't. That's okay. We can still leave it as 14 root 3 over 3. You might think it looks gross. It's perfectly fine. It's gorgeous. It's beautiful, just the way it is. You're beautiful just the way you are. And I hope you know that. Now that we have our short side, we can get our hypotenuse by multiplying by 2. Our short side is 14 root 3 over 3. We're just multiplying that by 2. What's going to end up happening, this 2 and this 14, 2 times 14 is 28 root 3 over 3. That is our hypotenuse. Might not be the prettiest answer, but it's a good answer nonetheless. Okay, I think that covers it all. So we learned a lot of tricks and rules. This is my summary. So in 45, 45, 90-degree triangles, we learned we could go from a side to a hypotenuse by, let's see, what did we do? Multiplying by root 2. We could do the reverse by dividing root 2. Then we learned 30, 60, 90. We can go from our short side to our long side by multiplying root 3. We could go from our short side to our hypotenuse by multiplying 2. We could go from our long side back to our short side by dividing root 3. And maybe I should say, or we could go to our hypotenuse, from our hypotenuse to our short leg by dividing 2. These are the 4 tricks and patterns we have learned. Thank you for sticking around with me to learn this very beautiful, not confusing at all lesson. If you / when you have questions, email me, talk to me in class. Adios, goodbye.